Hi guys, welcome back to the channel. So today we are going to be looking at the today's LeetCode question, which is task scheduler. So we are given an array of tasks, which is CPU task, and then each is represented by letters, which is from A to Z, and there is a cooling time n, and then each cycle allows the intervals to complete one task, and then tasks can be completed in any order, but there is a constraint that identical tasks must be separated by at least n intervals due to cooling time. So we need to return the minimum number of intervals required to complete the task. So we are given the task and then we need to complete this task with particular constraint, which is based upon the interval. That means we should keep this much interval, like n interval, before completing the identical task. Suppose let's say we are given this particular task. Now when I want to complete a, I'll complete a, and let's say there is no constraint. That means we need to return the minimum number of intervals required to complete the task. That means it can be completed in any time. Suppose let's say if I take this particular interval, so this is going to be completed. This will take one time, and then this will take two time, and then this will take 3, 4, 5, 6. So when we don't have any constraint, we are going to take it as the number of whatever the length is present that we are going to consider. So that means we are going to return the task dot size. So we are going to return this particular thing. Suppose let's say I have I have a constraint that I need to have at least one interval between each element to be completed. That means I will consider A, and then again I'll do B, and then again I'll do A, and then again I'll do B, and then again I'll do A, and then again I'll do B. So at the end of this particular interval, we are going to say all the tasks are completed with the interval gap between them will be 1. So let us suppose take n equal to 2. That means we are going to give the gap between them to be 2. So whenever I'm completed with A, I'm going to complete the B, and then when I want to complete again A, it is given that we should give at least 2 intervals. So this will be idle for some time. For this particular interval, this will be idle, and then again we are going to consider A, and then again B, and then for this we are going to consider idle. So this will be idle for some case. Now let us take one more thing, which is C. So this will have one more C, where it contains, this is the particular task. For this particular case, whenever we have C, instead of being idle, we can assign this particular C. For this case, it is going to give us the size length plus number of idle slot which are present in between the tasks. So whenever we want to find this particular interval, we are going to consider all the tasks which needs to be completed, which are allotted to slots, and then we are also going to consider some of the idle places which are present in this particular array. So that's what we are going to see. And then one more thing is, suppose let's say we want to make partitions between this particular interval. Suppose I want to make here as my partition. So this will be my partition. Why? Because whenever I keep A, and then the next A will be started here. That means we are going to consider one more case for this. So this will be again partition. Why? Because again we are repeating with A. So this is going to be like partition, and then number of idle elements plus number of the size length is going to be our answer. So we are going to calculate that. Suppose let us think differently, like how we can get the idle places, and then how can we assign this particular task between the partitions. Suppose let's say I have only one task which is like A's frequency is some 10. Now I need to have A, and then idle places will be like 10 times. It will be 10 times. 10 times idle. And then again I am going to consider A and then 10 idle items. 10 idle intervals. So this is how it is going to be constructed. That means we have this particular in this particular partition, and then we have this many idle elements which are present per the partition. So we need to calculate in such a way that it needs to be distributed. All the A's must be distributed between all the partitions, and then we need to calculate these many idles which are present in this particular partition, and then we are going to calculate the number of partitions which are present, and then we are going to multiply the idle intervals with the number of partitions, so that we'll get all the empty slots, and then we are going to add the empty slots with the task, and then we are going to return the answer. So let us check how we can solve. Suppose let's say I have the frequency which will store the frequencies of the all the elements which are present in the task. Now if I get all the elements, then I must use the tasks which have more frequency. That means I am going to consider whichever has the maximum frequency, that I am going to use it as for doing the partition. Suppose A has more frequency, then I am going to start with A, and then it will include all the idle items. And then again when I come to B, which will have like 3 or 4, then I am going to consider again whatever the idle places which are left, I am going to use those B, and then here as well B, and then here as well B. Now if I have C, I'll also use C. For this, it must be like all the frequencies must be same. And then after I am done with this particular case, let us say that D has only 2 frequency. D has 2 frequency. Now I need to arrange D in such a way that it must be the interval must be n places away. So that means D will be considered here, and then D will be considered here. And then let's say I have E where it has a frequency of 3. That means I'm going to consider E here, and then E is going to be here, and then again E is going to be here. So I'm going to use like this, and then whatever the available tasks are there, I'm going to arrange in such a way that it will be distributed among the whatever the left places are present. Now I am going to use after using all the elements, there will be some idle places. So these idle places, I'll add it to the number of tasks which are present, and then I am going to return the answer. So to do this particular case, I am going to consider the maximum count, which will store the tasks which have maximum frequency. So this is going to store, let's say the A frequency is 3, and then B's frequency is 3, and then C frequency is 3, and then D has a frequency of 1, and then E has a frequency of 2. That means I am going to take maximum count as 3. Why? Because A, B, C has maximum frequency which is 3. So I am going to count maximum count as 3, and then maximum frequency as 3. Now this will be counted with the 3, and then again I'm going to have the maxi value, which is the frequency of I. So this will store the whatever the maximum frequency any task can have, that is going to be stored, and then I am going to calculate this particular length. What is that? What is the length of this particular item? Suppose if I want to take this particular partition length, then I'm going to say partition. Let us calculate the number of partitions. Number of partitions is going to be like this will be one partition, and then this will be one partition, and then this will be one partition, and then again this will be one partition. That means whatever the this will be one partition, and then this will be one partition, and then this will be one partition, but we will not consider the last one. Why? Because it will not have any idle cases. Why? Because we will not be using other than this a b c e. So I'll use these partitions. So it is going to be maximum count minus 1. These are the number of partitions, and then let us find the partitions which are left idle. That means it is going to have the partition length is going to be the total length, which is going to be n plus 1. This is going to be n plus 1, and then out of this I am going to use the maximum. So I am going to use all the I'm going to use the maximum count, so that it will reduce all the a's and then b's and then c's, whichever all are used. So and then whatever the idle cases will be present, that will be my partition length. Suppose now I want to calculate the idles length. This will be the partitions which are idle, and then now I am going to consider number of idle places, which is going to be maximum, which is going to be number of partitions, and then we are going to multiply with partition length, that is the length of idle places which are present in this partition length. So this is going to give us the number of idle places, and then let's say we have used all the tasks which have maximum frequency with the maximum count. Then we will have some other available tasks which needs to be filled, that we will consider as some available tasks. Available tasks is going to be total tasks, and then total tasks size, and then maximum count, and then we are going to consider the maxi, which is going to be the frequency of this particular element. Now we got all the idle places, and then we got available tasks. So in this idle places, we are going to place this available tasks into number of idle places, and then whatever the idle places which are left, that means these needs to be left idle itself. We cannot reduce those idle places, and then whatever the available tasks are used, those will be used in this task dot size only. So we are going to return the answer as tasks dot size plus the idle places, which is going to be these number of idle places and then available tasks. So this is going to become like idle places is going to be this one, and then again this one. We are going to reduce this many tasks, and then at last we are going to return the answer. So for this case, if we consider the time and space complexity, the space complexity is going to be big of 1, and then time complexity is going to be big of n. Why? Because we are not considering any of 2 for loops or 3 for loops. So that is going to be the time and space complexity. So let's go through the code once. So I'm taking the frequency, which will store the frequency of the particular task. So and then I have counted the frequency of each particular task, and then this will store the maximum count, and then this will store the maximum frequency of a particular task. Suppose let's say the frequency is maximum, that means this is going to be the maximum frequency any task can have. That means we are going to increase the maximum count to maximum count plus plus. Suppose let's say we come across the frequency where it is greater than the maximum frequency, then we can say that this particular frequency will become maximum, and then the maximum count will become equal to 1. And then we are going to declare two things, which is partition length and then number of partitions. As we have already seen, there will be some partitions where we'll arrange the arrange the task. One partition will be having one a, and then again for next partition we are going to have one more a, like that it is going to have. And then in this particular case we are going to arrange the elements which have a maximum frequency. Suppose let's say the maximum frequency is 3. That means we are going to assign a and then a in different partitions, so that it will have the distance of n intervals between all the partitions. And then we are going to consider the partition length which is left out for other available tasks to be completed. That means after getting maximum count, as the maximum count contains all the frequencies which have that particular frequency, so A will also use, and then B will also use, C will also use, when the frequency of the elements will be always like same. And then whenever we are considering the partition length, this partition length is going to take only the places which are left after using the maximum count with the maximum frequency. So those will be some idle places which are left as of now. And then now we have these many empty places which needs to be filled via remaining task. So those will be these number of partitions, and then whatever the partition length which is left out. This partition length will be left out as n plus 1 will be the total interval, and then we are going to consider these many tasks which are completed for this particular partition. And then what are the remaining tasks which needs to be completed? For the task, we the maximum count with the maximum frequency we have already filled, so we are left out with the other task. So that is going to be task dot size minus maximum count and then maxi. And then we need to calculate the idle places which are left out after filling all the tasks which are present in our task array. That means we are going to consider the empty places which are left out as of now, and then the remaining tasks which needs to be filled in the places. So now at last there will be some idle places which we cannot remove, but those needs to be left such that it will have that interval of none n, such that the task will be having that particular length n, which is a cooling time. So that is going to be considered, and then we are going to add it to the task, and then we are going to return the answer. So that is it for the video. Yeah, thanks for watching the video.